AI itself is changing so much, and
Yep.
so many organizations have all these plans, but it's sort of like Mike Tyson said, everybody's got a plan until you get hit in the mouth, right?
Absolutely. We do what we call game days. We simulate incidents and we have them respond as if they're real production incidents.
Yeah.
And without fail, the first time, the team will totally fail to organize and coordinate. They will forget to allocate a lead. They'll forget to communicate out what's going on. They'll just dig into the technical issue, and then before you know it, it's all gone. But it's very funny because the second time around that you do it, everything goes totally differently because you've learned to calm down and you remove that adrenaline response and you get into actually how you should be running the thing.
Any day, within like weeks, a matter of weeks, the underlying systems underneath you can change drastically. How do you sustain a development effort in those kinds of worlds?
The truth is, I think that you have to be very selective.
Welcome back to IT Visionaries. I'm your host, Chris Brandt, and today my guest is Lawrence Jones. Lawrence is the founding engineer at Incident.io and formerly a principal SRE at GoCardless. He has spent years responding to high-stakes incidents and now leads AI development for tools used in some of the most stressful moments in engineering. He's here to break down how to build AI that works, not just AI that demos well. Lawrence, welcome to the show.
Hey, Chris, thanks for having me.
It's great to have you. And I mean, I don't know, would you consider this like category more in the AI ops category, or like, you know, like you're coming from an SRE background. So like, how would you classify all of this?
Yeah. So, I mean, as a company, Incident.io, we provide an incident management solution. So we're very focused on helping people like SREs actually respond to incidents, but also a lot more broader than just SRE. So dealing with organizational issues. A lot of us come from fintech backgrounds, so that bleeds its way into the product as well.
And fintech is very demanding too.
Oh, yeah,
regard.
no, for sure. There's no accident that I think myself and Lisa, who joined a bit after me, and all the three founders are coming from a fintech background. Like, those incidents are really nasty, and it teaches you a lot along the way.
Yeah.
But no, so the role that I'm doing at the moment is more of an AI engineering role. So I've transitioned from site reliability engineering to spending, I think, about 3 years at Incident doing product. And now it's product, but with AI threaded all the way through it.
Tell me a little bit about like why you chose to go to Incident, and like what was, you were engineer number one, I understand. So like right after the founders, it was you. So
exactly,
they did all the fun stuff, and you had to do all the work, it sounds like.
Yeah, well, we can keep that bit in. I'll enjoy that.
Yeah, well, but so tell me like what it was that attracted you here.
So I used to head up infrastructure at GoCardless, which is a scale up in London. So we had about 800 people in the company at the time that I left. That was about 250 engineers at that moment. The stuff that I was dealing with there was really, really high stakes, horrible financial incidents or availability issues. So lots of people taking payments to our platform. If anything went down, any moment of unavailability where the API wouldn't respond would mean people weren't able to take payments. That's obviously something that people care about a lot because that's immediately lost cash and a burnt customer relationship. So it kind of puts you on the spot when it comes to these incidents. And you really, I think I was always attracted to incidents, but gradually over my time at GoCardless, I kind of grew to love them even more, if that's possible, which was why when Pete and Stephen and Chris were building what was the early stages of Incident, which at the time they called Pineapple, a little Heroku dyno running the very basic version of what the platform is today. Pete reached out and went, hey, like, you run a load of these incidents at GoCardless, can you have a look at this tool? And at the time, one of my teams were considering booting one of the open source alternatives. So actually, Monzo's Response was one of them, and Netflix Dispatch that helps you run incidents at GoCardless.
Right.
And I just had no interest in them trying to learn how to run this thing themselves if we could end up buying it. So even the very minimal kind of basic solution that Pete showed me at the time was something that I really wanted. And it was at that point that I guess I started thinking, well, actually, this is a product that I can see us going so many different directions with this thing. And I think that was probably one of the reasons that Pete tapped me on the shoulder in the first place. So eventually ended up leaving GoCardless to come join as the first engineer here. And then I've been here for 4.5 years trying to build out what has since become much more than that first product.
So it's interesting that you say you love incidents. I've seen that in a lot of people. You know, a lot of people they like to be in the mix, having a deterministic problem to solve, whereas in projects, you don't necessarily have those kinds of things. But at the same time, it's also a hard spot to be in because, you're constantly being yelled at by, why isn't
Yep.
this up? What's happening? Give me the stats. How much longer? So like, what is it about that attracts you?
Yeah. So I think there's so many like great things for your personal development from working with incidents.
Yeah.
I think one of the most beneficial is you get to see how your organization really works. So you have all of this hierarchy and structure in an org. But when something has actually gone terribly wrong, any of the process or the hierarchy that has been put in place starts giving way to kind of the true structure and of how you get things done in your organization. So you get to interact with people from all sorts of different teams, see them kind of working in their best light, honestly, like when under a lot of stress, but also performing at the top of their game. And I always found that really, really great, actually. So you get that from seeing it through other people and you get to meet a bunch of people, but you also get to test yourself in a situation where the stakes are really high. And actually, if you can do a good job, you can make some really meaningful impact to the company, hopefully by reducing the negative impact.
In your experience with incidents and now looking at incidents from the other side of it, I guess, in some ways, what do you see that is the most common mistake that companies are always making and like why these things are so difficult?
I think at the heart of good incident response is communication and coordination. And that was exactly where we end up starting incident. So honestly, and before you have a tool like incident, usually your phone would go off and you'd probably get a message, probably an SMS that goes, "You've been paged." And you'd have no idea what it is. And you probably jump immediately into some dashboards. You start debugging. 5 minutes later, maybe you found something, maybe you haven't. And actually maybe 5 or 10 other people's phones have gone off and you have no idea. And you're all separately debugging things and you got like, no one knows what's going on. And customers may be reaching out to your support staff. They have no place to go to get you or even know who's responding. And that stuff just spirals out of control really, really quickly.
Yeah.
And it's obviously it is the most natural thing to do. If you do get paged, you jump into, I want to fix the problem. But actually it's kind of, you've got to put your own like oxygen mask on first, basically. You have to wire yourself in and make sure that the organization knows what's going on. And that's what a tool like Incident does. So nowadays we'll page you, we'll collect all the alerts together that actually look related. So you won't get paged many times. You'll just get paged once and we'll drop you in an incident Slack channel. So where you're going to coordinate all of your response for this. That's publicized to anyone who needs to know. So if people come in on the customer support lines, they go directly to that incident channel and they know exactly where to get you. And whenever you're doing anything inside the incident, you're communicating out. So if you have an update to give about the impact or the thing that you're doing to try and resolve it, that goes out through the tool and it notifies anyone who needs to know, as well as a bunch of other stuff that we do to aid you on the way with incidents. But that's the stuff that most people, I would say, get wrong, often just due to lack of experience or lack of anyone telling them how to do good incident coordination. But as soon as you can kind of crack that, and a tool does help a lot with that, incidents start feeling a bit more like a well-oiled machine.
So many organizations have all these plans and they do a lot of planning for these things, but it's sort of like Mike Tyson said, everybody's got a plan until you get hit in the mouth, right?
Absolutely.
And what I think that from what I've seen in a lot of these instances, you're right. I mean, you want to jump in and fix the problem because it's like, well, maybe I can just fix it real quick, but it's usually more of a marathon in these types of things than the sprint. And taking your time and understanding the context of what's happening is really a hard discipline.
Yeah. I'm kind of going back to what you said about Mike Tyson. I think it's always funny. So we do what we call game days incident, where in order to train people on how to do good incident response, we simulate incidents and we have them respond as if they're real production incidents.
Yeah.
And without fail, the first time that you run one of these things, you want to do the day so that you get 2 runs at it. Because the first time, the team will totally fail to organize and coordinate. They will forget to allocate a lead. They'll forget to communicate out what's going on. They'll just dig into the technical issue, and then before you know it, it's all gone. But it's very funny because the second time around that you do it, that can be just an hour later after doing a debrief, everything goes totally differently because you've learned to calm down and you remove that adrenaline response and you get into actually how you should be running the thing.
Nowadays, obviously there's your usual outages that every company faces. Some piece of gear fails, some code is inserted that's wrong, or just, something scales out of control or whatever. But I think another big one, and I think it's the one that most companies fear the most, is the cyber extortion event, right?
Yep.
And the response to those two things is very different, right? And so like, when you walk through with people about like, how are you going to respond to, like, well, the network seems to be down. Like,
Yep.
what do you do? Is it down because this is like something we need to take everything down for? Or is this, we got to get it back up and running right away? Or, like, let's shut the machine down. It's like, well, if it's a cyber event, you don't want to turn the machine off. You just want to disconnect it, right? So you preserve all that evidence. So like, there's a lot of like conflicting patterns that start to emerge. Can you talk about how you help resolve some of those problems?
Yeah, no, for sure. So the work that I've been doing for the past year and a half has been working on what we're calling our AI SRE product. So this is using AI and building what has since grown from a more simple system into multi-agent, like orchestrated system that basically kicks off at the start of an incident, and it starts looking at the alert that's come in. It looks at all of your dashboards, so telemetry, metrics, logs, traces. And then it also goes back through our platform and looks at all of the incident data that you have stored, including things like postmortems that have been authored against those incidents. So including all the information about what you did right, what you did wrong, what you said, please, next time, let's remember to do this next time. And it ends up compiling that into a hypothesis about what we think is going on and provides you with a bunch of next steps that go, hey, by the way, this actually looks like a cyber incident. And last time when you did a drill on this, you said that you need to be escalating this directly to your CISO. And all of that stuff is captured inside of our platform, but it's a huge amount of information. And part of what we're doing is trying to help you sift through it and do the right thing, even if you haven't been to the training, or maybe because you've forgotten the training, or it happens so rarely that this thing doesn't even come up.
Yeah.
And not just those incidents, it can be financial incidents, or just like you said, like the technical incidents, say the AWS outage that happened last week.
Oh yeah, that was a big one.
That was a big one.
It's great that you have this kind of information collated. I mean, when I've worked on incidents, man, to walk in and just have like all that in front of you, because the problem is like, it's both the lack of information and it's the abundance of information, right?
Yes.
Once something goes down, you get 1,000 tickets coming at you. Maybe they're for the same thing, maybe not, right? So
I think this is where AI is kind of uniquely suited to help. The truth is that you are limited as a human on how many tabs you can open and read at the same time.
It's not for lack of trying and opening tabs, though, let me tell you.
No, I mean, yeah. That's why you buy the machine with more RAM, right?
Right.
But no, so I think when we first kick off the investigation, we can consider hundreds of different dashboards or different theories, and they will all run in parallel, and we'll get you an answer that has discounted a lot of the needles in the haystack that turned out not to be the needle you were looking for, and get you a report within a couple of minutes, often before you've even actually got to your laptop after first being paged. And that's a huge amount of stress and work that you've removed from the critical path of you solving that incident.
I also just want to jump back a second to something you were talking about, SRE, because I don't know that everybody understands what SRE is. This episode of IT Visionaries is brought to you by Meter, the company building better networks. Businesses today are frustrated with outdated providers, rigid pricing, and fragmented tools. Meter changes that with a single integrated solution that covers everything: wired, wireless, and even cellular networking. They design the hardware, write the firmware, build the software, and manage it all so your team doesn't have to. That means you get fast, secure, and scalable connectivity without the complexity of juggling multiple providers. Thanks to Meter for sponsoring. Go to meter.com/ITV to book a demo now. That's meter.com/ITV. I mean, can you talk about like coming from Google and, where it's evolved to?
For sure, yeah. So Google coined the term, or at least popularized it. They've got a book on it, which is always a good read. Honestly, like SRE as a field has kind of ended up encapsulating this idea of a software engineer who solves reliability challenges and helps your organization operate at a high level while enabling your developers to balance those business needs with the operational ones that you might come from having high availability requirements. So that's a load of words for really you end up with very technical people who have studied and learned how to run systems in a reliable way while having an appreciation for how to balance those reliability concerns with what the business needs from software engineers delivering on a day-to-day.
Yeah, and I think we saw a lot of discussion about SRE in the early days, and then it kind of drifted off because everybody's going to do SRE. Then they found out how difficult it actually is to do. Yeah. I think they sort of changed their tune.
I think there was a lot of like literature that came along with the Google SRE book that works really well at their scale. maybe in some places at Google and less so in even within Google. And there was a lot of like cargo culting is a very strong term for what this is, but it's like everyone wanted to do it properly, right? And Google are the people that you look at as the people who do it properly. So people were going, well, we need SLOs and we need SLIs and we need error budgets. And I think all of these things are tools, and like many tools, you need to know when and if to apply them. So I think what's become, or what has happened, is that SRE teams have settled into a rhythm of what makes sense at the scale of company that they're operating in. And it feels much more natural nowadays, especially when that type of process or that type of team glues really well with the commoditization of cloud hardware and how cloud infrastructure providers actually operate now and the tools that they ship to people.
Yeah. Well, and it's probably bad form for, like mid-sized enterprise folks in mid-sized enterprise just go around and randomly turn off systems to see if it is a dependency or not.
Yeah, and I think there's been sometimes you can lose track of what's really important, and I think this is actually part of what being a good SRE or even just like a really good product engineer is. It's about knowing how much tech to use and how much technical excellence to aim for within the context of what you're trying to deliver. And I think actually the SRE book did a really good job of saying this, which is like, you shouldn't be aiming for 5 nines. You need to pick what the appropriate range of availability is for you, because
and engineer to that.
Exactly. You shouldn't underestimate the cost of going from 3 to 4 and then 4 to 5. It's probably the case that your business can't afford to or does not want to pay the amount of resource that's required to try and get you there. And that's okay.
And you mentioned the book, and the book is an amazing read. We should. This is a note here to put a link to where you can find the, because I think it's available in like a free PDF or something like that.
Yes, I think so.
But it's a fascinating read, actually. That's not just for geeks, I think, but maybe it is.
No. Maybe. Well,
maybe. So let's. I mean, you're deep in the AI side of things now. It sounds like.
Yes.
So let's talk about some of the challenges of developing AI in today's world.
So I think both like the annoyance and the wonder of all the generative AI tooling that's coming out is that these models are so capable of doing so many things that if you try and build a prototype of something that you've never been able to see built before, often you can end up with a prototype that looks so incredibly promising so very quickly. And it has real sparks of brilliance, and you're using it and you're like, oh my God, look at what it does. Like, this is amazing. And it's only when you try and dig into it and try and understand how will I actually use this? Is it good enough? Oh, wait, that's actually giving me a response that doesn't really make sense. How do I fix that? It's everything that comes after getting the prototype that is actually really hard.
Yeah.
And I think the story that kind of gets this for me is the investigation system that we put together. I started prototyping it, I think, before Christmas last year. And I think we built out a ton of AI tools at this point. So we built a chatbot and we knew kind of how to do it, but actually building a rudimentary investigation system. So the AI SRE product that we have now, the very basic version, took me about 3 days to put the flow together, and it looked really good. it looked great. Like we turn it on and had a look at what it was doing. And then we had our team try and use it and give us feedback. And immediately you realize this is not usable at all, actually. Right. Even the stuff that when you first look at it and you're like, oh, that looks impressive. You start digging a bit deeper and you're like, well, either that is not true, or if it is true, I need to see why you got to that. And I need to see all the work that went into it. And suddenly you start realizing that put up against the test of real users using the thing, this is going to be a real slog. And that comes out in almost all the different AI tools you've got. You can build a chatbot that works for 70% of your queries really, really quick. The real question then is how many of your users will enjoy using it if 30% of the time is wrong.
What I've seen is all the models, the generative AI, it's very good for it can be very good. If you take a systems-based approach to doing anything you're going to do, it can be very good, but it's good in discrete amounts. And so when you're talking about doing something at scale, and this is why I think there's a big disconnect between MVP and sort of the, at scale kind of implementation, because I don't think there's enough context in any of these LLMs to really build a big system, because then you have to think about the architecture. You have to figure out how to abstract things. And there's a lot of moving pieces that it just can't hold in its head all the time, right?
Yeah, absolutely. And I think it's not even that. I mean, fundamentally, you're limited by this idea of how much context can you put into one prompt. But The reality of most large or sophisticated AI systems nowadays is you're not talking about one prompt, you're talking about hundreds of them wired into each other. So it's a non-deterministic chain of errors that compound as it goes through. So one mistake that starts in one prompt can end up echoing out in like this terrible whisper chain into something that can become really substantial and really problematic at the end.
Yeah, for sure.
So you have to, in order for you to actually build the system so that it works, you have to understand architecturally what the different pieces are, and you have to pin them down and formalize them. And then you have to learn how to measure each part of those systems and understand what is a good measurement and how you're even going to tell if it operated correctly. You know, like you can't use the same AI with the same information to go, did you make the right decision? Because it will probably go, yeah, it did, because it has no knowledge. Yeah, exactly. Like the chatbot will decide, unsurprisingly, to do the same wrong thing again. That does kind of make sense. So you have to figure out what you're doing to measure this stuff, and then you have to figure out how to build that into your development chain. And you have to do that not just for data that you have in development, but for data that you have in production and beyond just your account, for data that might look very different in other customer accounts. So it's a really, really hard challenge.
AI itself is changing so much and it's so fast that it's like you may, like just a great example is like Anthropic just added memory into Claude, right? For example, so you used to have to manage, moving from one session to the next and, moving your context along with you. But now it's got this concept of memory, which kind of works. But I mean, that's, like any day within like weeks, a matter of weeks, the underlying systems underneath you can change drastically. How do you, sustain, a development effort in those kinds of worlds?
This is really hard. I did a panel yesterday on AI development, and one of the people came up to me afterwards and was like, I like lead AI at this company, but I'm finding it so hard to deal with the influx of everything that's coming in. Like, how do you keep up with all the research? Like, how do you know that you're doing? And the truth is, I think that you have to be very selective in what you're looking for.
Yeah.
And just the same as all software engineering, you should not be racing to use every bit of new tech just because it's new tech. So I think there's been a couple of themes with that in AI that I think are quite interesting, where I think when we first started and we were building out a load of RAG pipelines, vectorization was a big deal, like embedding,
right?
Where you would take a document, you pass it through an embedding model, it will give you a vector back. And then there were these vector databases that could do cosine similarity and quickly give you the things that look semantically similar. So it's essentially search, but done using generative AI principles. And we went to go use vectors because everyone was saying these are the ways to do it.
Well, you know what, before you go on, I think it's interesting, and I think it's important to understand what a vector database is and like how that works. If you could just kind of touch on that.
Yeah, for sure. So there are a ton of like actual first class vector databases out there where they support this natively, but you can actually just install indexes. So if you're running a conventional database like Postgres, so standard relational SQL database, you can install PG Vector and it will allow you to work with these vectors that are produced by these AI models. But at its heart, all you're really doing is you're representing a document in terms of its meaning in a vector, which is how these LLM models are understanding these documents. And then when you say, I would like to find things that look similar to this vector, you're running what is quite a simple mathematical calculation, which is called cosine similarity, to try and find the other documents in the database that look like they're as close to your vector as is possible. So you can kind of see it as trying to match the signatures of all these documents up against one another if the signatures encoded the meaning of the document.
Yeah.
So for us, what we were doing was we were taking a bunch of GitHub pull requests and we were running them through embedding models to get the vectors, right. So that when we ended up with an incident and we went, hey, look, this incident has gone wrong for this reason, it's affecting all of this stuff, we could then encode what we thought the incident had gone wrong with and find GitHub pull requests that looked like they were legit or looked like they were most similar using that cosine similarity from our database. And I think everyone really ran quite hard at vectorization and then have since kind of backed off. And there are tons of reasons for that. It turns out that vectorization is really quite difficult to get right. There's a bunch of concerns like chunking and all sorts that affect the performance of pulling things back that are similar. And we've ended up going back to like really simple techniques that are a lot more debuggable and understandable. So typically what we do now is we pass a bunch of these code changes through an LLM. we ask it to tag the code changes and to summarize them. So it just comes out with a really simple summary of everything that's gone wrong. And now we fall back on text similarity. So standard, like just searching through text to look for things that are similar.
Yeah.
And that works honestly better than we were able to get the vectorization to work. So, and I think that's happened a couple of times over in AI, where if you rush to grab the new technology, you can maybe end up on this boat that doesn't actually have much mileage in it, or maybe there are more simple ways to approach the thing that you're doing.
And just to put that in context, that's something you were probably working on last year. I mean, that's how fast things have changed, right? Because everybody was doing that with RAG models, and that, I mean, like literally months ago,
Yeah, the pace of change is, I mean, whether or not you're looking at the research, I think the actual thing that you need to do is, I think, approximately every 3 months with this idea of the investigation system that we've been building, we had to take a look at the landscape and go, well, what is actually now possible given all the changes that have happened? And the ambition that we had went from, we'll give you a good summary of everything that's going on and maybe find you some links, to, we're actually going to try and deep dive into this and give you a root cause analysis. So tell you, we've looked in your logs and everything, and like, this is actually the problem. And now we actually try and fix it for you. And so we're drafting code changes and trying to fix your code with the system that we've gone and built, so that ideally you don't even need to do anything yourself.
Wow.
And I think that change in product ambition is actually almost even more dizzying to me, honestly. And that's changed over the course of a couple of months, as each time we went, oh, wait, but we could do so much more now than we thought we could before.
With the help of AI, you can develop things a lot faster now. I mean,
yes,
I feel like almost you can overrun your design. You can easily quickly find these things, and you go back to look at your PRD, and you're like, this has nothing to do with anything I'm building today, right? I mean, so like, how do you manage that?
I wish I had like a good answer for this. I really do. I've worked a lot, like many years, in API design, and you have kind of a similar problem there, which is when you're trying to build a system or an API that other people are about to integrate with, the cost of change later is really, really quite high.
Right.
But also, you don't want to be doing this thing where you don't get anyone to use it until it's all entirely built. So you have to really try and balance the pace of delivery against the amount that it will cost you if you've made mistakes. And it's kind of like a measure twice, cut once sort of situation.
Yeah.
And I think that's been the same with us. So every time we've tried doing something with AI, we've rapidly tried prototyping it. And then when we've hit stumbling blocks where we've gone, oh, actually, if only we had this tool that could let us do this, we've kind of stood there, stopped, and then gone, okay, well, what would that tool look like? And we'll try and consider it from a very generic perspective. So thinking a bit further ahead than just the use case that we have now.
Right.
And then we built that tool and then proceeded from where we left off. And what we've actually ended up with is something that is a really solid toolkit that's helping us build AI products in many different ways. And we haven't made too many missteps with that stuff. That stuff hasn't changed that much. But we could so easily have just canvassed a bunch of odd tools that didn't really make sense together. And if we'd have done that, then we'd have ended up with a real mess that probably wouldn't have been very useful to us at all. It is very hard to do, but I think knowing when you can stop and take stock and think a bit further ahead than the thing that you're just trying to do at this present moment, it's probably a good idea to do so.
I'm sure you have success stories and specific use cases that you've seen, could you talk through how somebody used this to really solve their problem?
Yeah. So, I mean, I can give you an example. So I think the best examples are ones where I can actually share the context properly, which is really like production incidents for ourselves. So just like the other week, one of our external integrations, they had a bug or they had an issue. And as a result, what happened was we ended up getting some queues backed up because we weren't able to contact them. We got a bunch of errors. So what happened was the incident got created in our system, and it could easily have looked like it was a code change because someone had just deployed a code change around this external integration about an hour before. So it starts looking quite highly suspect, and people are always on alert at that point, right? Because you're like, oh God, I shipped that thing just before and I'm getting paid for it now. So what our investigation system did was it turned up and it had a look at the alert, and it ended up looking through all of the recent changes, and it did find the change that we just shipped. But at the same time, it was looking into the Grafana dashboards and looking at the error rates of these integrations. And it went, well, my hypothesis at the moment is maybe you shipped this change and that's caused the problem. And in order to try and refine that hypothesis, it ended up going, well, actually, I don't know if it is this code change. Like does the code change align? Also, have we got any other issues with other integrations? Because this was a code change that was impacting more than just this integration. So can I go rule that out? And it starts taking a load of pictures from my Grafana dashboards and browsing our logs. And it goes, actually, well, I've just realized this is not actually impacted by this code change because it doesn't quite line up with when we deployed stuff into Kubernetes. I've also confirmed that the other integrations that would have been impacted by this are not seeing error rates because I've gone and filtered the dashboard in the right way. And I've got these charts here that show me that that's not the case. So I'm actually going to go browse the internet. And then what it did was it ended up finding the status page of the external provider and going, oh, they've got an incident up actually. Like they're having an outage. And all of this happened within the first 3 minutes. And what we got was an investigation report that went, hey, like, look, I know you shipped this change, but I've gone and ruled it out. I've had a look at the code actually, and I'm pretty sure the code's fine. And then I've also confirmed that this isn't impacting the other things. And I've also found the status page open. So it looks to me as if this is not a thing that you need to deal with. You can calm down. Don't worry. It's all fine.
Oh my God, it was a network problem at the end of the day.
Yeah. I mean, I was looking through the questions that it was generating, and it was actually like, it might be a network problem at the pod level. So it ended up browsing into the network metrics that we have, outgoing connections from the pods. And it was like, no, actually, I've seen no change in outbound network connectivity. So it doesn't look like we've got a network level issue. So it kind of canvassed all these angles. And I think that's the power of this thing. It can go, I've got 25 questions I need to answer, and I can do all of those at the same time and tell you what's important.
Oh my God, I would love to have something like that in the past, because and that's a really interesting use case you're talking about. Because let's like kind of bake that down to like what would happen if you didn't have something like this in place.
Yeah,
right? You pushed a code change, an hour later or so, everything went haywire. So like that's the first place, like you said, that's the first place you're going to look. You're going to look, well, the code looks good. Maybe this sped the system up and now we've got a race condition somewhere else, or we've got, like a resource issue in something else. And then you go chasing that down. You'd be reviewing code, looking at logs on all the servers. And it's just really an upstream issue that you have no control over anyways. And that could have taken 2 days to figure that out.
I mean, you may even have reverted it, right? Like if you've got a thing that you've deployed that could be powering a new feature, but you think that might have caused a real serious problem because this thing was just hard down. Honestly, one of the first things you consider is, before I take the time to understand the code, if it's safe to revert, I'm just going to revert it, which could have caused even more problems. And
then everything else comes unraveled.
Exactly. Yeah.
It's like, I forgot about that, other dependency that I have. Yeah.
Exactly. And if you were on a team that wasn't familiar with the code change, perhaps you would have found it and you'd have had even less certainty about what to do. And you may not have even known at that point is, should you go wake someone else up? So there's a ton of human considerations around this as well. If you can be a lot more intelligent about what actually the problem is, hopefully you can avoid having to wake up 10 people just in case it was any one of them who may have caused the issue.
Well, and I imagine your system's very, very busy at about 5 o'clock on Friday too, right? Because that seems to be when everything happens.
Yeah, everyone needs to get in their deployment before they go home for the weekend. That's just life, I'm afraid.
As somebody who's like got visibility into many environments that are troubleshooting issues, right? Do you see that kind of a pattern? IT Visionaries is powered today by Meter, because every great business relies on great networks. If you're a network engineer, you know how critical uptime, control, and visibility are. Too often, you're stuck troubleshooting issues across fragmented systems or locked into legacy solutions that don't scale. Meter reimagines networking from the ground up. Their full-stack solution, from ISP procurement to security, routing, wireless, and beyond, gives you deep control and the performance you need. No more piecing together providers or worrying about bottlenecks. Just seamless, scalable connectivity built for today and tomorrow. Big thanks to Meter for sponsoring. Visit meter.com/ITV to book your demo now. That's meter.com/ITV.
I mean, in answer, yes. Like I think one of the great adages of working in reliability is that it's change that causes issues.
Yeah.
So it should be no surprise that essentially the volume of incidents and things going wrong is directly proportional to when people are working on those systems. Saturday, Sunday, like you come along, our stuff is barely whirring. Really, there's really nothing going on other than perhaps some poor team somewhere who's dealing with, I don't know,
Yeah.
streaming service. That's not great. But yeah, other than that, it basically just follows the working hours of the people who are working on these systems that they're trying to look after.
I think that's a really interesting thing right there because, like we talk about, the bulk of incidents are introduced by people, and like to have like that, visibility into that dynamic is really fascinating, I think.
So actually thinking about it, so when I worked at Go Cardless, Go Cardless is a recurring payments company and they deal in bank debit payments. So it will be a lot of like monthly payments taken. So naturally you end up with these anchoring points of working days before the first of the month is when suddenly there's a big crunch in the system and it goes wrong. And I remember at one point I could actually see in our incident volume, particularly in the amount of hours that have been worked on incidents, you could actually see the working day periods. Presume maybe not just finance, maybe there are other industries out there that are anchored to these dates, but it is funny what you can read into the data.
Yeah. No. And it just, I mean, if you want an operating safe environment, just send everybody home. And I think system should be okay.
Yeah. I mean, I hate to say it, but code freezes do work. I mean, they make things safer, but a system that isn't online is often the safest. So it's
no users, like everything unplugged, right?
Exactly. Yeah.
So walk me through like some of the functionality of how this works. I mean, it's amazing to have like all those hands to go out and do all these different things and bring this kind of telemetry back. But you have to like integrate with a lot of different systems. I mean, in the fact that you're even going out and polling the upstream provider and things like that. I mean, that's a lot of stuff you have to integrate with. How do you like how what's the process of like identifying all those points of data?
Yeah, so I tend to think that we're quite an advantage for this actually, because most companies doing this type of work are much newer than us actually.
Yeah.
But as an incident response company, if you imagine when incidents actually happen, they tend to involve people from across the company. And when they happen, you want them to happen in one centralized place. So since the birth of the company, we've had this kind of push or a motivation or an ask from our customers to integrate with increasingly more of the tools that they use in their stack. So I often thought when I first joined the company, and I think it shaped a lot of how we built things here, that one of our core technical strengths needed to be integrating with external systems and modeling information from those systems really well inside of our product and allowing people to ask questions about them and understand them. And what that meant is that going into building this AI SRE product, we can already see things like all of your CRM data. We even have access to HR platforms because people like linking us in so that we can see paid time off, so that we can tell you when you clash on your on-call rota. So we have a wealth of stuff in our system that allows us to end up pulling all of this stuff into the model and going, well, actually like, oh, I see that this incident was the same last time, but you created some follow-ups last time and you exported them to Jira. Oh, I've actually just seen there's a follow-up for fixing this thing, but I can see that the follow-up isn't complete. In fact, you deferred it or you canceled the ticket. So that probably explains why we're seeing it now. And then you can end up surfacing that to the person who's unfortunately been paged for the thing that they went, probably don't need to fix that the week before. So yeah, like I think we're kind of ahead of the game on how you can connect into all these systems. And then technically the challenge just becomes how do you structure that information and turn it into something that you can properly use inside of the investigation system. But we've developed quite a few muscles and tools to do that by this point.
Well, so let's ask that question then. So how do you like present this? I mean, because you're taking data from a lot of places, and like obviously AI is great at like collecting data and summarizing it. How do you take all of that and boil it down to something that is actionable?
What we do is continually along all of these integrations that we're going to use with our investigation system, we are connected to these systems that are sending us webhooks. So we're continually ingesting information from your upstream systems. And often we have what we call processes, which is this abstraction around receiving some information from an external place or even internal actually, and then passing it through frontier models to end up pre-processing it and turning it into something that we can then index and make appropriate for searching in real time.
Hmm.
The investigation system then kicks in when you end up with an incident. And because we pre-processed all this data and because it's indexed in all the right way in our databases, we can end up pulling the data that we think is most relevant to the incident really, really quickly. So we essentially like use this very overpowered RAG pipeline for the first 30 seconds of the investigation where we boil the ocean to find anything we think might be useful. It's at that point that we've kind of prepared your workstation. You can kind of think of it as like you're in the war room and like everything that you need or might be relevant is on the desk in front of you.
Somebody just dumped a stack of papers on your desk.
Yes, a stack of papers that we think are probably quite useful. We've done some level of shortlisting, but at this point, the reasoning engine kicks in, and we go through all of this information and we model them in what we call findings. So we go through and we go, what do we think is interesting here? And these findings are essentially factual observations that we have from the data that we can see. So we can go, hey, we've seen a spike in this graph over here, which implies this thing. Or maybe we've seen that this incident over here mentioned that you should do this in a different place. We then take all of those findings and we turn it into a narrative. So we try and construct a narrative of what we think has happened, like a causal chain of all the different things that we've seen along the way that could lead to the alert that we've seen has caused this incident. And that turns into a hypothesis. So at this point, we have this idea, like great idea, based on all these findings that we've observed. This is what we think has actually gone wrong. But we don't stop there because like that hypothesis is probably quite weak at this point. So we end up with this other agent that kicks in and goes, hey, like grill us. Like grade this hypothesis, tell us what's weak and tell us what questions you would like to ask. If you were like interviewing that responder and you're like, I don't really trust you. I'd like to know actually, all these other integrations impacted, or is it just this one? We take all those questions and then we pass them off individually to various other agents, which are just responsible for answering the questions that we've given to them. They can then use all the data sources that we've got, like telemetry, like old incidents, like web search, even checking documentation. And then when they end up with an answer, that gets fed back into the original reasoning system, which updates the findings, which then causes us to turn again on the hypothesis and go, actually, I've gone and strengthened this now, or I no longer think this is true. This is actually what I think is going on in the system. It's that hypothesis that we then end up turning into a summarized report that we go drop inside of the incident channel, where we're saying, hey, this is what we think is what's happened. We've checked X, Y, and Z. If you want more detail, go here. Here's what we think you should do next. And then if you want to go into more detail, we have this dashboard view where you can check all of the rationale that went into what we've gone and built. So we have links to every external asset that we've gone and got. If we say in this incident, you did this, you can click on it and it will take you directly to the place in the channel that person went, oh, by the way, I ran this command, and like we'll give you some context about whether or not that was a good idea or a bad idea. Please don't do it if it was a bad one.
So is that all happening in Slack, like a Slack channel, for example, or a Teams channel or something?
So it's a Slack channel or a Teams channel that you get the abridged report. And the attempt with that report is to be as concise and brief as possible. We want to tell someone who's extremely pressured and maybe quite stressed out, this is what we think the problem is, and here's where you go for more information. When you want to go for more information, that's when you duck into our dashboard and you get a proper full page view of everything that we found, where you can dig into the data at any different level of detail.
So, and then are you then sort of recursively analyzing that Slack channel to see what people are doing in real time?
So I think this is kind of the cool thing, because we are constantly listening for all the messages and anything else that's going on in the Slack channel. We're also scanning all of your integrations, so we know if the alert resolves or if we see other incidents that are being booted up. Whenever we've seen that there is a relevant kind of like package of information, we end up bundling that up and we pipe that back into the investigation system, where it makes a decision on whether or not it needs to adjust its findings or change its hypothesis based on what we now know. And if we've changed our hypothesis substantially enough that we think that a responder should know, when we conclude our next turn of the investigation, we'll go pipe back to the Slack channel and go, hey, actually, based on what I said last time, I don't think this is the case. I actually now think it's this, and here is exactly why I think so.
Yeah, that's interesting. I mean, and because you have, like all these systems and agents along the pathway too, I imagine that gives you a lot of transparency into the sort of the thinking process as it goes too, right?
Exactly. And I think, like, for example, we have a code agent that is really good at analyzing code bases. So when we have a code base that we think the error exists in, we'll pull down the code base and we'll load it into that agent. And then that agent is available for the duration of the incident, and we can fire questions at it, and we're sharing context between that agent and all the rest of the agents. And whenever those agents find anything interesting, they basically feed that back into the main reasoning engine, which will then go update its findings. And then when it updates the findings, it will go, which agents do I think need this information? Which agents do I think this finding changing would be relevant to? And if it finds any, it will go send the information directly to those agents, and we'll do another turn, which eventually will lead to, again, more updated findings and then hopefully a stronger hypothesis.
So how do you, I mean, I guess you kind of answered this question I was going to ask anyways by, like kind of having these, evaluating the veracity of sort of your outputs. The question I was going to ask is like, how do you avoid blind spots? And is that sort of the main mechanism how you do that?
So I think the attempt for us is that we will get better at only giving you information that we can properly verify. And when we can't, we'll tell you what we think is the problem, and we'll tell you where to go next to verify it if we don't have access to it. And we will appropriately communicate our level of confidence to you. So if we are giving you anything that's speculative, we should be flagging it as like, I'm not sure about this, by the way, but this is probably where I will go next. I think this is actually particularly interesting when you're considering running this across many different customer accounts, many of whom we don't know intimately, right? And this is what we've actually pushed into our scoring engine and our evaluation tools. So whenever we get to the end of the incident, we end up grading each one of these investigations against what we actually see through the incident channel the responders actually did to solve it. And we have various different labels that allow us to go, well, this investigation was either good or it was bad, but it was bad because not because we came up with bad results, but because we couldn't see a part of the system that was actually essential to doing the response. And I think for us, this is a case of us trying to figure out, when we look across all of the many thousands of investigations we're running, what was it about the tooling that we need to either improve, or do we need to flag to a customer that actually, if only we'd have had access to that code base, we would have been able to fix this much faster, so that they can both manage what we have access to and find out where our blind spots are. Because inevitably, when they start leaning on this more, our blind spots become their blind spots.
Right. Well, and I think that's something that I find missing in AI a lot, is sort of like, like AI's, you're absolutely right.
Yeah.
I've definitely found the answer, right? I mean, it's like, it's 100%, like positive on everything. But like AI really needs like confidence level scores for every comment it makes, right?
Yeah. So like, I mean, a system like this is just not, it's just not good if it is confidently wrong.
Yeah.
In fact, actually, I go further and say it's not even good if it's confidently wrong like 5% of the time.
Yeah.
It only needs to be confidently wrong in a couple of small cases, and suddenly you broke trust with people who need to trust your system.
Big time.
And you can address that in many ways. Like the way that we do this is we expose a lot of the thought process that went into why we came to a conclusion.
Yeah.
So if we've ever came to a conclusion based on telemetry, we're linking you directly to that dashboard or to those logs. So we can tell you what we think we saw. But if you're working your way through it and you're like, I'm not sure that that's quite right, you can click and you can go check it really quickly yourself. Also, going back to kind of this idea of an ambient agent, if you are just chatting in the channel, you can literally just talk to us and go, hey, like that doesn't look correct. And we'll end up modifying our interpretation of that finding and going, actually, we've got concrete evidence from a responder that that's not the case. And we'll end up working that back into our hypothesis. So it's very much, honestly, you start thinking of these things much more like you would a human who's helping you with the incident, rather than this system that's just running wrong in the background.
Well, and it cuts both ways too, because sometimes you have like AI being very confident in its findings and gaslighting you, but on the other side, sometimes you have humans that read that and they're like, you're absolutely wrong. No way, it's just an AI. You're stupid. And like, but the AI is actually right. And you're like, so it does like, and one of the things that AI is not good about is standing strong when it's right, always. Too, right? And you get that. That's where you get that. You're absolutely right. I don't know what I was thinking. And like, no, you were right. Why are you telling me I'm right?
Yeah, I think the thing with all of this is there's a positivity bias that's been worked into the models, because it kind of has to. Like at the end of the day, they are great predictors of the next token. But if what you have provided is a confident statement, then like you are much more likely to predict a confident summarization of what you said. But equally, you can combat this, right? So there's this idea of like a critique or like kind of agents that you use to fight back against your positivity. So a common pattern that you use is a prompt that is meant to produce or speculate about, for example, a hypothesis. And then you combat that positivity bias by using an equally positive agent to go, you're absolutely wrong, and giving you loads of the questions that you would otherwise grill this person with. And if you then take those questions and you work them several times over in another agent and come to a conclusion and try and back it with evidence, you can kind of explore the problem space really quite thoroughly until hopefully evidence is what underpins everything that you're understanding. And at least if it does, then, and it's wrong, you can quickly as a human check in and be like, no, that graph has actually been dodgy for ages. You shouldn't be trusting that data at all. But
right. Yeah. Well, I mean, sometimes it's like it's standing in a room with like 20 people who have like wildly different opinions. Some people are, just like can barely function, like to feed themselves, and the rest are like super specialized at this thing, and you're getting opinions from everybody. Like it's a hard problem to solve for.
It is. I mean, the good news is in an incident room where the cacophony of all the noise of these people all working through their individual threads, in a room where that wouldn't distract everyone and drive them insane, that would actually be the ideal situation, right? Because you'd split 10 different ways and you'd have everyone looking at all the options. The good thing is with AI, you can actually do this and you can segment the system so that hopefully you're not distracting people with noise, but you are doing a thorough analysis of everything that might be possible.
Yeah. So how much of this is just, are you providing information, and how much of what you do, if any, is actually taking action?
So I think we started with this stuff thinking that we were going to take a pretty hard line on, like, we're not going to do anything. I think the way that people have been interacting with AI machines has been very much, it's changed. And the way that they've interpreted the level of safety or risk with an AI making decisions that can take physical actions is changing on a monthly basis.
Yeah.
So I think initially we thought we would just give you, this is what we think is going wrong. And then gradually we started realizing, well, there's tons of stuff that we can do that isn't exactly necessarily fixing it, but it is proactively going some way to fix it. Mm-hmm. So the things that we do now that are really impactful, if we think that we found a bug in the code, we will start already drafting the pull request that would try and fix it. So we don't go as far as actually merging the thing, but we do get you a PR that's signed and sealed and green, hopefully in your CI, and dump that in the incident channel and go, by the way, I'm pretty sure this is the thing that's the problem. If you just merge this, it's going to fix it.
And just for reference, PR pull requests and
yes,
a lot of things there.
That's my bad. Yeah. So a change to the code base that you go submit to your version control like GitHub. But it does mean that you could potentially be paged for this issue. You could even, and I think we are considering doing this later, holding back the initial page. If you've said this is an error that actually I don't mind waiting 5 minutes for you to try and fix, we could even try and make a best attempt at triaging and fixing it in advance of us actually waking someone up. So the dream is really that this AI SRE product is auto-resolving a bunch of your incidents or doing the first level triage, because honestly, AI doesn't need to sleep as much as humans do and gets way less grouchy when you wake it up at night.
Yeah, for sure. So I know you guys, you're a growing company, and I know you guys are you're trying to scale up, and obviously finding good AI talent is really hard. One, I would love to ask you, like, how are you finding people to do this kind of work, and like what do you look for in folks like that?
Yeah, so I mean, people may disagree with me on this, but I think the realization that we've had is that there aren't really anyone who had, when people put out job ads and they're like, you need 20 years of experience with Kubernetes. And everyone laughs because they're like, well, that thing's only like 10 years old. So I don't know what you're really talking about there.
Whoever wrote this has no experience with Kubernetes.
Exactly. And when it comes to AI, it's kind of the same, honestly. All of the stuff that we're doing right now would have been impossible a year ago. So people just simply couldn't have possibly built it. So trying to find people who have expertise and like years of experience in this is, you're not going to find them. They don't exist. So what we have to do is we try and find people who are going to be good at the type of work that this is. And I will soften this not at all when I say this work can be really grueling and honestly horrible. I think several of the engineering team describe it as like the roller coaster team, just because it's so up and down. Honestly, you can get something that looks like it works really well, and then suddenly you realize it doesn't. And you can have weeks where you put in lots of hours and realize at the end of the week that was just not a good idea at all, and you've got to throw everything away. So it's really hard. The thing that I found most compatible with the work is you have to find people who are both extremely methodical thinkers.
Yeah.
And they think a lot about the system and the impact of the change that they're making that goes beyond just the part of the system that they're dealing with. I think that's a reflection on, with these AI systems, one prompt is wired into so many others that you have to end up building a really good intuition about how, when you change that prompt, what is it going to do to everything else? And those people are often the people who have like really strong ownership over when they ship something. When it goes into production, they're the people who would normally be going and checking the feature immediately when it lands in production, and then looking at all the dashboards and confirming it's working for customers in the way that it really should be.
Yeah.
And really holding themselves to a high bar on being like, actually, that's not quite perfect. And I'm gonna kind of obsess over making that thing good.
Yeah.
And the other angle is, in a team like this, you really need people to trust each other and to be able to take very like hard feedback. You can end up working on a prompt where this is the first time you've worked on that prompt and you've gone and tuned it and you've spent a couple of hours making changes and you think you got all the evals in. And then you get a review from the person who has spent 20 hours last week working on it. And because we don't have the technology to really map out kind of the probabilistic space of these prompts, the best proxy for you understanding what this prompt is going to do and how it will work is the intuition that someone has built over those 20 hours working with it. So you can often end up opening a PR and that person will go, no, sorry, as in like, I spent ages with this last week and I can tell you, you've added that sentence there and I know it makes your eval work, but that as a whole has made the prompt worse. So you have to get people who trust each other and like each other enough that they can deal with that on a daily basis.
Yeah, yeah.
I actually think there's a huge amount of parallels here between the AI engineering role and SRE, where I think people who've worked on non-deterministic systems, where the consequence of a change that's made kind of well-intentionally but is wrong, can be very catastrophic. You have to work kind of slowly. There are like longer feedback cycles as you have to more thoroughly test things. You can't YOLO stuff. And you have to be okay when someone's like, actually, hold up there. Let's take it slowly. Think this through really carefully. I've got some, burnt fingers from many years ago when we did something similar. So let's just, take it easy.
You're absolutely right about the systems-based approach to it and sort of the non-deterministic nature of these things. Because, you could write the best prompt ever, and for whatever reason, the LLM will just at some point decide to ignore it and altogether.
Exactly.
Which it does a lot. Part of your job is like dealing with, really idiot savant kindergartners, with the AI.
Yep,
right?
exactly.
They know what one thing, like, and then just run away. But I think the other thing is like, in addition to having that sort of systems kind of approach to things, you do have to have like a wide area of knowledge too. And like one of the things I've heard people talking about is like not looking for like the computer science people so much, but looking for the liberal arts people more.
Yeah.
What's your thought on that?
So I think we, like one of the best prompt engineers, so not liberal arts, and Millie will crucify me for this, but Millie's background is in like a data analyst and some machine learning adjacencies, and expertise and experience being so thorough and working through like all the different edge cases and trying to build up like a rapport of how something works. That really, really shines in how she works with these systems, and the stuff that she can do where she spends a lot of hours with these tools and gets really familiar with them. Suddenly she can take a prompt and reduce it by 3/4 of its size, and it suddenly passes way more evals, and as a result is far less overfitted. And I think someone that I was listening to a podcast, and there was a very senior AI engineer, I think at like DeepMind or something, that said, it's extremely disconcerting to me that there are some people on my team who are at least 5 or 10x as good at prompt tuning than anyone else, and they can't tell me why, and they can't seem to teach anyone. And it's like, I honestly, it is a bit of an art, but I think that the art follows people actually obsessing over it and really caring about it, and it does come with practice. But there are just some people who are much more inclined to practice, which is not necessarily a judgment on anyone, but they love getting punched in the face. And those are the type of people that you want on a team building these systems.
Yeah. So, well, I mean, and I know you're looking for people too. So like if somebody wants to, like deal with all of this and it has that systems-based approach, where should they go?
Oh, without a doubt. So yeah, Incident IO Jobs is where you want to go. I think we hosted our conference just the other week, SevZero. It's all about incident response, but we did a demo of demo of the AI SRE on stage. And it was later when I was watching someone else's talk that there wasn't enough space in the room. We'd maybe overpacked it a bit. And I was sat on the ground next to this guy. And after the talk finished, he turned around, and I never met him before. And he went, you're really, really lucky, because loads of engineers want to work on like a Golden Gate Bridge project. They want to work on something that's really, really significant and would really change things if you do a good job on it. And the thing you're building is that. And I think it's really easy for me to forget that this is happening when we're doing it on a daily basis, and some of it is really, really hard. But the truth is, if we can get there, and I believe that we can, getting to a system that can actually stop people from being paged overnight, can solve a load of these issues for people. Yeah. There's genuine impact to be had there at both a human level and like obviously like at a building of amazing product and an amazing company level. So yeah, I would, if this sounds interesting, please do check out Incident IO jobs. We're scaling aggressively. So
yeah, no, I think that sounds great. I mean, I think it sounds like a super cool project. Like in my past, I could have used this.
Yeah.
So many times. I mean, like this would have been just super valuable to me, in my career. So yeah, keep up the good work. It's super, super interesting, fun conversation. I love talking about this stuff. Great to, get to know more about you and what you're doing, and congratulations on your success so far.
Yeah. Well, thank you very much for having me on. Yeah. It's always fun learning out about this stuff. So yeah, thanks for the great chat.
Yeah. Thanks.